Assalamu alaikum friends, my name is Raja Usama and in this tutorial we will cover the basics of remote sensing. Do you know that how, what, when, where, why do satellites collect data for us? So in this tutorial we will see that what is it and how it's work, why it's such crucial tool in the field ranging from environmental science to urban development. But first, let's start with a question. Did you ever notice that why the plants appear green and the sky appears blue?
नहीं
Okay, after watching this tutorial, you will become able to understand all these things. So first of all, I am going to tell you that what will be covered in this tutorial. We will see the basics of remote sensing. What is the importance of electromagnetic spectrum in remote sensing? What is atmospheric windows and band of Landsat 8? What will happen if we will composite or stack all the bands of Landsat 8? What are natural colors and what are false colors? What are active and passive satellites? Basics of satellites, type of scanners, resolution of satellites, level of datasets, and what is SLC in satellite, and what will happen if SLC will fail in any satellite. Okay, so let's explore this diagram. So first of all, you know that the word remote mean without going in touch with any feature, and sensing mean the collection of data. So you can see over here there is a source of light that is A, and it is sending its energy or radiations toward the Earth's surface. But at atmosphere, the sunlight is interacting with our atmosphere, where the refraction, and scattering take place. After that, this energy reached on Earth's surface, where it hit any target or any features on Earth's surface. This feature and object transmit, absorb, and reflect different amount of energy. Again, different features on Earth's surface reflect, transmit, and absorb different amount of energies. This reflection and absorption then recorded by a satellite. Recording of energy take place on this point at D by a sensor, and then transmission, reception, and processing take place. After that, the interpretation and other corrections on raw data like geometric or radiometric or other corrections take place, and then that data is available for use, for public use, or for other uses. Okay, now we will understand what is sunlight, and we will explore the sunlight with the help of Uncle Newton. And here the Isaac Newton perform an experiment that he passes the incident rays that is directly coming from sun through a prism, where it split that light in 7 different colors: violet, blue, and through red. So after splitting this light, he performed an experiment. He put a thermometer above and below the blue and red light, and he observed there is a temperature variations over here and over there. So then he predict and he said that there is other light present in incident ray, that we cannot see that light. Our eyes are not able to see that spectrum. That wavelength of lights is said to be visible portion of light, and other portion of light like infrared lies over here, and then short wave infrared and so on. They are invisible light for human beings, but not for satellites. So now let's explore the sunlight with the help of electromagnetic spectrum. This is the complete light of sun, but we can see only this range of sunlight that is known as visible range. The rest of light, that is gamma rays, X-rays, ultraviolet, infrared, shortwave, infrared, microwave, and radio waves are invisible for us. So here you can see that the blue color is starting from 0.4 to 0.44 picometer, and ends, the visible range is ending on 0.7 picometer. So the primary colors are only RBG, red, blue, and green. Other colors like yellow come from this RBG. They are known as CMYK colors. When we will combine blue, green, and red energy, it appears white. So you can see over here that here the length of wavelength is shorter as compared to here, but the energy of this wavelength is very high as compared to this wavelength. So the difference between the distance between two wavelength or crest of wavelength is known as lambda. So you can see over here this rainbow. In this rainbow, the water droplet of rain are actually acting like a small prism. When sunlight passing through them, the droplets split that light into 7 different colors. So you can see over here the light with shorter wavelength, blue and violet color, are in the inner part of the arc of rainbow, and the longer wavelength like orange and red are along the outer arc of this rainbow. Okay, now in this diagram you will see that why the waters appear blue. So water appear blue because when the incident ray of sunlight come and fall on water, it reflect blue light more as compared to other colors. Like green is more reflecting as compared to red, and infrared is completely absorbing by water. So blue light is reflecting more by water, so it appear blue to us. Okay, now with the help of this diagram, we will see that why the plants appear green to us. So in this diagram, you can see there is the wavelength of IR red and green and blue color. When the red and blue color fall on a leaf, uh, these two colors absorbed by the chlorophyll of leaves, and then they used in photosynthesis purpose. But green light is reflected by chlorophyll, so plants appear green to us. Percentage of green light reflecting by a plant is approximately 10%, but the percentage of IR infrared light is nearly 50% to us, but we are unable to see infrared light, so the plants appear green to us. But if we was able to watch the infrared light, so the plant appears too bright for us. So here is the answer of my second question, that why sky appears blue. Actually it is due to Rayleigh scattering. Rayleigh scattering occur when the particles are very small as compared to the wavelength of radiation. So you can see that in sky, the short wavelength, that is blue color, and only short wavelength of blue color is visible to us. So blue color scatter more as compared to other colors in sky. Due to scattering of blue color, the sky appears blue to us. There are other type of scattering also take place in atmosphere, like Mie scattering and non-selective scattering. But you can also search and read about these scattering. Okay, now let's understand the term of spectral signature. So the spectral signature is the variation of reflectance or emittance of a material with respect to wavelength. As we know, and I mentioned in earlier, that every object on Earth's surface has its own reflectance and absorption. So now here you can see the water has its own reflectance and absorption. It reflects light in blue, green, and red wavelength, but suddenly he absorbed all other wavelength after near infrared. So as in vegetation, you can see that at 0.5, that is the band of green, there the vegetation give 10% reflectance, so it's appear green to us. And after, when it reaches toward near infrared, it has a peak of 50% reflectance, so vegetation appear too much bright in near infrared. But as you can see that after 1.3, there is a deep valley, a sudden absorption of wavelength by any object. If come in a graph or in spectral signature, that is known as valley. You can also see the spectral signature of soil. So if we will see the spectral signature of cloud or snow, that will start from over here from 80%. Okay, now let's understand what is the term of atmospheric window, and after this we will study and see the bands of Landsat 8 or 9 over here. So atmospheric window, the region of wavelength that completely absorbed by atmosphere or unable to reach on Earth's surface. That zones, these gaps, these zones are unable to reach on Earth's surface due to absorption on atmosphere by carbon dioxide or water molecules is known as atmospheric windows. Okay, so now let's go toward the bands of Landsat 8. Here you can see this is the first band over here on this wavelength before blue band, that is near 400 nanometer. So the first band of Landsat 8 is known as coastal band. So let's see this band on arc map. Okay, here you can see this is the first band of Landsat 8 and this is known as coastal band. So this is also used for the coastal studies. It has two major functions. First one is it tells us about the concentration of aerosols, and the second purpose it use in atmospheric correction of the image. Okay, now we are on second band, that is the blue band, and you know that the blue wavelength is completely absorbed by vegetation and used in photosynthesis purpose. So the vegetation over here is appear as black, but you know that the blue color, the water reflect blue color more as compared to green and red. So this water channel is appearing quite bright. And similarly for the third band, that is known as the green wavelength band of Landsat 8, the energy that is reflected by vegetation is just only 10 to 12%, and it also reflects the amount of water. So water is also appearing bright. And the fourth band, that is known as the red band, the red energy is completely absorbed by vegetation and it's completely look like dark, and the water and other area that have some reflectance of red color are quite bright as compared to this region. And the fifth band of Landsat 8 is known as near infrared band. As we know that when the water enters in near infrared, it completely absorbs all the wavelengths of spectrum. So water is clearly appearing black. This band is also used for the study and extraction of water bodies. And the vegetation you can see over here, the vegetation reflect 50% of light in near infrared. So the vegetation is appearing so bright as compared to in green color that is only reflecting 10% of wavelength in green color by vegetation. So let's go toward the 6th and 7th band, that is known as short wave infrared 1 and short wave infrared 2 band. This band is used for the study of dry and wet surface of earth, also used in geology, or this band is also help in the study of built up areas. Okay, now we are on 8th band, that is known as panchromatic band. The panchromatic band produces a black and white image, but its spatial resolution is 15 meter as compared to other bands. These bands have the spatial resolution of 30 meter. After this, we will also see what are the resolutions and what are the types of resolution. So the panchromatic band is actually the fusion of three wavelength. As you can see over here, 2, 3 and 4th. This panchromatic 8th band lie in 2, 3 and 4th region of light. So it sends more wavelength and produce a sharper image. A sharper satellite image will reveal more detailed feature of Earth's surface. So if I will zoom this image, then you can see the clarity of this image. But if I will go to this, then you can see its spatial resolution is 30 meter. Okay, after this we will also study the resolution of satellite. Okay, now we are going towards the 9th band of Landsat 8, that is known as cirrus band. Okay, cirrus band is actually used for the study of clouds. So you can see here we are unable to see the ground features, but the clouds are clearly appear over here. But if we will turn on this image, then you can see there is no cloud over here. So this band is very useful for the study of clouds. Okay, let's go toward the 10th and 11th band of Landsat 8. These band having the spatial resolution of 100 meter. So don't worry, we will also discuss about the resolution of satellite. So these two bands are actually the long wave infrared bands. They detect the heat, the amount of heat, the land surface temperature of the scene in an image. Now let's see what will happen if I will make a composite of or stack of these bands. So go to your search tool and search a tool that is known as composite band. Use this tool. Select all your bands and drag over here. Now you can also select your file destination, band composite.if, and hit OK. Okay, now you can see over here that after using this tool, we have got this. Now we can see our bands in RBG. Means we will see our bands in these three different colors. So if I will see the fourth band, that is a red band in red color, and third band, that is green band in green color, and second band, that is blue color in this band composite, then you will see this is the natural view. This is the natural view of our image. So this is known as natural color. And if I will make a composite of 5, 4 and 3. Now this is a false color combination because we cannot see the near infrared light of fifth band, but we are watching this band wavelength in red color. So as you know that the near infrared light is reflected by vegetation about 50%. So the vegetation is appeared too reddish in this picture. And similarly, we are watching the fourth band in green color and third band in blue color. So this band combination is perfect for the study of vegetation. Okay, now we will make another composite for vegetation, that is 6, 5 and 2. This band is also very helpful to study the vegetation. Now you can see over here the fifth band, that is near infrared band, but we are seeing that band in greenish color. So the amount of near infrared light is reflecting by vegetation approximately 50%. So we are watching that energy in green color. This is also false color. So for land, water, okay, another combination, that is 5, 6 and 4. This is also used for the extraction of water bodies, like the water bodies and the land is clearly differentiating each other in this scene. Okay, now let's go toward our sensors. Means satellites or any drone. There are two types of sensors: active sensors and passive sensors. The sensors that detect and measure natural radiations that is reflected or emitted by object on Earth's surface. In simple words, the sensor that require and depend on the energy of other object, that is known as passive sensor, as the Landsat 8 and Sentinel-2 are the examples of passive sensors. In this image, you can see that this passive sensor depend on this source. This light come and reflected by this target, then this sensor will collect the data of that target. But in case of active sensor, they emit their own energy in pulses or in electromagnetic radiations or others, like in sonar system is, for example, the sonar produce its own waves. So like active sensor create and generate their own pulses. They hit on the target and again the pulse return back to the sensor. Then it detect the data. So radar set 1 and 2 are the example of active sensors. Now what is the path of a satellite? A path that is followed by a satellite is known as its orbit. Just like this, like our Earth revolving around the satellite, it has its own orbit. So like other satellites have their own orbit. And what is sun synchronous? Sun synchronous are also known as heliosynchronous orbit. Is a nearly polar orbit. Polar orbit mean they start from north pole to south pole or south pole to north pole. They are polar. They have polar orbit. So they nearly polar orbit around planet in which the satellite passes over any given point on planet surface. Mean कि our satellite pass from any point of Earth surface at the same local solar time when sunlight is available. So they are synchronized with sunlight. When they passes through any surface of Earth, the sunlight will always available at that point. So what are ascending and descending passes? So our satellite that are passive sensors collect their data when they moves from north pole to toward the south pole. Mean in descending path they collect the data and then again they ascend toward the north pole. So what is the swath of an image? Swath of an image is actually refers to the total area on Earth's surface covered by seen on a satellite. Here, if I will measure, if I will measure the swath of this image in kilometers, then you will see that this will approximately 185 kilometer. So this is the swath of a satellite. Next, what is nadir point? The surface that is directly below to our sensor is known as nadir point. What are the types of scanners? There are two types of scanners in the satellite: a cross-track scanner and a long-track scanner. So a cross-track scanner scans the Earth in series of lines. In lines are orientated perpendicular to the direction of motion. But in a long-track scanner, it scans perpendicular to the flight. Mean it will scan all the line, all the row at once with a linear array of detector. So in this video, you can see that there is what is the major difference between a cross-track scanner and a long-track scanner. They are also known as whisk broom and push broom scanner. Okay, now we are on our resolution point. So this is also a basic concept of satellite imagery. So first of all, there is the type of resolution. First type is spatial resolution. Size of smallest resolvable feature on ground is known as spatial resolution. The spatial resolution of Landsat 8 is 30 meter and Sentinel is 10 meter and for MODIS it is 250 meter. So you can also say the pixels of the imagery of these sensors is also known as spatial resolution. Let's see a pixel of Landsat 8 that will be 30 meter. Let's go to arc map and we are on our blue band. Okay, if I will go to this pixel over here, and this is the one pixel of this image, then it will approximately 30 meter from here to here. So this is 30 meter, and we know that in panchromatic band, that is eighth band of this image. And if I will go to its 1 pixel, so as we know that the panchromatic band have the spatial resolution of 15 meter, so its 1 pixel will approximately about 15 meter. So this is the spatial resolution of satellites. Let's go toward the spectral resolution. So the ability of sensor that can sense different wavelength of electromagnetic spectrum is known as spectral resolution. Like Landsat 8 has 11 bands like coastal band, blue, green, near infrared, SWIR1, SWIR2 band, and MODIS have 36 bands. So what is temporal resolution? The revisit time of a satellite on same place on Earth's surface is known as temporal resolution. So the temporal resolution of Landsat 8 is 16 day, and for MODIS it is daily, and for Sentinel it is 10 day. So what is radiometric resolution? The ability of sensor to distinguish small differences in brightness of light received from Earth's surface is known as radiometric resolution. So from Landsat 1 to 3, their resolution is approximately 4 bits. For Landsat 8, it is 16 bit. Radiometric resolution actually help us so we can distinguish between the brightness, the amount of grayness in imagery. So if you want to download the image of a Landsat, then you can click on top right corner. Here I have told that how can you download the imagery of Landsat, and in now if you will click on this link, then you can also see that how can you download that data of Sentinel-2. So if you want to download the data of Landsat 8, then when you will go to the USGS Earth Explorer, you will find there are 3 types of data. So level 0 data is actually the raw data measured by sensor, and the level 1 data means that data has radiometrically and geometrically corrected, and for level 2 it is also atmospherically corrected data. So what is SLC? SLC is actually, there are many instruments used in a satellite. Like I have told you that it has a scanner, like it can be a push broom scanner or whisk broom scanner. So for scanning those rays of sensors in satellite, they use the scan line corrector. Scan line corrector is used to remove zigzag motion of imaging field. Okay, imaging field of view produced by a combination of along and cross track motion. So what happened if SLC will fail? So with Landsat 7 in 2003, its SLC become failed. So here's the imagery that is available from Landsat 7 after the failure of SLC. You can see over here. Okay, that wraps our tutorial into the basics of remote sensing. I hope this video was very helpful for you. Okay, if you found this information helpful, or if you have any question, feel free to drop a comment below. And don't forget to give this video a thumb up if you enjoyed, and subscribe my channel to more content on remote sensing and GIS and on photogrammetry in future. So remember, the world of remote sensing is vast and ever evolving. Stay curious, keep learning, keep exploring. If you have a specific topic, then you can also suggest that one. So many thanks. Take care. Allah Hafiz.